Hi class, this is Professor Smith. I'll be doing a movie on simplifying products or quotients of higher radicals with different indices, multivariate. So before we get started, let's do a little review of language. Here I have the square root of 4. Most often you don't ever see it typically written with the 2 here in the index, but it turns out that's what the square root means. And so the index of that radical would be 2. Here we have the cube root of 4, and so the index would be 3. And then the cube root of 5, the index would be 5. And the sixth root of 4, the index would be 6. So you can kind of recognize that the index is that little number written right there in the crossbow of the radical. So now what we're going to do is go ahead and do one of the problems in ALEKS, which says write in simplified radical form with at most one radical, and they give us the square root of xy over the sixth root of xy. And what we want to do in order to write this as one radical, we have to have this index of 2 and this index of 6 have a common radical. And we can think of that as like common denominators. And so I've opened up math type so that I can write in as I'm speaking. So I'm going to rewrite the top radical using the indice. Even though we don't normally usually write square root, it's understood to be that the square root has an index of 2. So we just most often don't write it. But I'm going to put the 2 there just so we can see more clearly. And then I'm going to copy the denominator. And so this has an index of 2, and this has an index of 6. And we can think of it as if we were adding fractions, and if we had a 1/2 and a 1/6. How would we get the common denominator? Similarly, we're going to think of that, how will we get the common index? And so since 2 divides into 6, the common index is going to be 6. So what I'm going to do is I'm going to keep the denominator the same because it already has the desired index of 6. And then what I'm going to do is I'm going to rewrite that numerator with an index of 6. And so I ask myself the question, how many times does 2 divide into 6? And so it goes in 3 times. So in order for the numerator to be equal, I have to make sure that the exponent on here has a product of 3. In other words, I kind of think of it as multiplying. 3 times 2 gives me 6. And this x to the 1 power, I need to multiply that 1 by 3. So I'm going to write it as x cubed y cubed. In other words, this could be simplified down to the square root of xy. Now that I have the same index, I'm going to rewrite this fraction over or underneath one radical. So I'm going to copy it. Actually, I deleted it. And write it downstairs. Let's move this up so you can see. So I'm going to rewrite this over one radical. So it's going to be the sixth root of the numerator, which is x cubed y cubed, all over the denominator of xy. So now instead of having 2 radicals with the same index, I have 1 radical. And then I'm going to simplify. X cubed over x, and then y cubed over y. And so that's going to give me the 6th root of x squared, y squared. And you think, oh my goodness, I'm done, yay! But it turns out, whenever the index and the powers have a common factor, we can simplify it even further. So 2 goes into 6 3 times. And so I'm going to change this index here to a 3 and have that x to the 1 power. So let's copy that so you can see what I'm doing. So I'm going to rewrite that as the cube root of xy. Similarly to what we did when we first started out, going in the opposite direction. If you multiply this index by 2, you need to multiply each of the exponents on the x and y by 2, giving you x squared, y squared, 2 times 3 is 6. All right, I hope that movie was helpful.